Hello, can you hear me? So this is going to being in English for the benefit of the recording primarily. How many people in here don't speak Icelandic? And for the benefit of you. All right. So today I'm going to tell you about how we built CrankWheel based on the Google Chrome WebRTC platforms, the general web platform, actually the general web platform of kind of 5 years ago, and with an Erlang-based server and backend hosted in the cloud. Now, before we get into that, how many of you have tried CrankWheel or have seen a demo of CrankWheel? Okay, a few people, not too many. So I think it's best that we start with a very brief overview of what it is, what it does, and I figured the fastest way to do that would be to show you a video. So I will just stand here and shut up for the next 2 minutes approximately. Oops. Can we turn up the volume?
That's a good question. We may have a problem with that.
Oops. Okay. Then I'll do the voiceover. Can you hear this at all, the voiceover? No? Okay, great. So that's better then. So basically CrankWheel is a Chrome extension which makes it really easy to install. You just click on a button there and you click again and now you're installed. And to use the system, you click the button that gets added into Chrome, and you can choose to share either the full screen or a program window, or you can share a specific browser tab, and we'll do that right now. We're just choosing which tab to share, and now we're sharing. We need to invite our customer into the session. We can do that in a few different ways. We'll use an approach called the reception lobby, where we ask our customer over the phone to type in a very simple URL, in this case meeting.is/cw for CrankWheel, which is the company where I work. It could be meeting.is/acme. And your customer can use pretty much any browser out there. And they start by seeing a little panel telling them who I am, talking to them, and saying that this is just a live video. We're not taking over your browser. And now on the left-hand side is the agent view, or the person who's showing. On the right-hand side is the customer view. You see that there's a little bit of a delay there. If you look to the very right edge there where I'm pointing with the mouse, that's what we call the preview pane. And the preview pane shows you exactly what the customer is seeing. You can see how the mouse movements get reflected on the customer end and how they also get visualized in the preview pane. So this is done so you no longer have to ask, are you seeing the next slide, or are you seeing this, or you're talking about something way before. Now if the customer zooms in, see how I can also tell that that has happened in the preview pane. Finally, I can invite more people into the session. I can have multiple viewers connected to the same session. And yeah, that's it pretty much. That's a very brief overview of CrankWheel, just so that you have the context for the rest of the presentation. All right, so let's dive into an overview of the architecture. It's a pretty simple diagram, right? The architecture is not quite that simple, but we'll start by explaining it like that. So to be able to display real-time video from the agent to the customer, what we do essentially is we're grabbing video frames on the agent end, and we're encoding them in a custom way into effectively a video stream that we can then display in any browser. So the reason we're doing a custom video stream is to be compatible with pretty much every browser out there. And it's sent in a similar fashion as most other video. Who here is familiar with the concept of keyframes? A few people. All right, so the idea with keyframes, and this is how normal real-time or any video is done if it's compressed, is that you get a keyframe every once in a while, and you can essentially start watching the video after you get a keyframe, because between keyframes you're only receiving delta updates that rely on knowledge of the keyframe. And the CrankWheel custom encoded video works essentially the same way. You remember the preview pane on the right-hand side? To make that possible, the viewers, the customers that are there, they're basically regular HTML pages with JavaScript, and they basically send back a report. I've just displayed frame number 3, or I've just shown mouse update number 5. And that's all the information that goes back, and we use that to reconstruct on the agent side what we should show in the preview pane. And now all of this communication flows through what we call a session server, and each sharing session is on exactly one server, and one server can handle hundreds of sessions at a time. All right, well, that's it. Thank you very much. Now it's time for Q&A. Just kidding. Let's go a little bit deeper than that. How about that? All right, to begin with, let's start looking at the technology stack that we use on one of the clients. So we have three different clients. This is one, is the agent client. It's essentially the client that the salesperson or customer service representative that is showing their browser or screen is using. So we build heavily on the Google Chrome platform. We don't really have to. We could have native clients. And in fact, I think we will have native clients on things like tablet computers and smartphones at some point. But building on Chrome gives us a ton of things for free and just shortens the development cycle. One of the things we get for free within Chrome is Chrome extensions that are available in the Chrome Web Store. That's where you go to get CrankWheel. And this is a platform that I used to work not on, but with when I was working on Chrome at Google. And it gives you a lot of things. It's basically a way to write extensions to the browser using just JavaScript and HTML. And it gives you things like auto-update for free. You get a pretty good security model. And you get access to the inner workings of the browser. And we actually use that when we're grabbing just the browser tab rather than the whole screen. We're using that access that we have. Another piece of the puzzle is called WebRTC. This is a part of the Chrome platform as well, although it can also be used standalone by standalone applications and things like that. And this is another project I actually used to work on at Google. WebRTC stands for Web Real-Time Communications. Who here is familiar with WebRTC? One person. Please join me on the stage. All right. So the idea behind WebRTC is essentially this. Imagine that Skype had never been invented, right? There was never a Skype or anything like that. And now somebody today was inventing Skype. Instead of writing a native application for each platform and writing video codecs and audio codecs and writing their own peer-to-peer communication layer, they would just write an HTML web page and JavaScript. How's that? So that's the WebRTC platform in a nutshell. So it gives you the ability to capture video from the camera, from the screen, capture audio, and send it over a peer-to-peer network. And right now we only use the client part of that, the ability to capture videos. At some point we may also use the peer-to-peer communication, but I'll talk about that a little bit later. All right. Anyone here familiar with Socket.io? Nobody? Yes, a banana for you, or a cigar. All right, so we don't actually use Socket.io, we use Engine.io, which is the fundamental library below Socket.io. I'll explain what it is. So each of the actors in the diagram you saw before, where there's an agent and there's different viewers, each of them logically maintains a persistent connection to our server while a session is going on. And what we used to do is we used to use just WebSockets. Who knows what WebSockets are? Yes, a few people. All right. So we used to use WebSockets, which is really a new web technology where you can just connect. It looks like a TCP stream if you're familiar with that. Can connect to a server. And what we used to do is we had WebSockets going over the SSL port 443, to get out through the firewall and to be encrypted and everything. And we figured that's going to work. That's going to work every time because getting through the firewall that way is a classic approach used by many programs. For instance, WebEx started using this back in '93, I think. It turns out some of our customers have firewalls that actually decrypt encrypted traffic and re-encrypt it, and it breaks WebSockets. So the reason we use Engine.io is that Engine.io will try to use WebSockets, but if they're not available, it will use what's called long polling over HTTPS. And what that boils down to is we can tell our customers, if your staff is able to use their internet banking on your intranet, then they're also able to use CrankWheel. And that's about as compatible as you can get, I think. So that's the agent side. So what about the customer side? So On the customer side, we have two different clients. We named them normal mode and basic mode. We're really original in our naming like that. We may add a third one, and it'll probably be called advanced mode. So normal mode, what is it? We use that for almost all browsers. Essentially, we use it for all browsers that have a canvas, support for the canvas element. Who is familiar with canvas in HTML? All right. So it's every modern browser, and it's actually a lot of really old browsers that support that. If we don't have support for canvas, we switch to what's called the basic mode client, and that one only requires very basic JavaScript support and the image element. And image has been around since the very beginnings of the web. The key takeaway is that any old browser will do. As I mentioned about WebRTC, at some point we might add an advanced mode WebRTC client that we would use when WebRTC is available on both ends of the connection. But I'll talk about that a little bit later, why we're not doing that yet. All right, just to give you a feel for it, on the left-hand side is a normal mode client, on the right-hand side a basic mode client responding to the same set of inputs, just so you can see what the difference is. So on the left hand we have the canvas, we can draw this beautiful live mouse cursor. On the right-hand side, it's a little bit slower to update, and the mouse isn't actually live. We just draw these kind of trails so that you feel like you know about its movement. So that's the main difference between the two. Really, on the right-hand side, we're just updating a big image as fast as we possibly can, but it's a lot nicer than that on the left hand. All right, so I'm probably making you cross-eyed already with all these videos, and I promise that's the last video. We'll just do like hardcore technology now. Let's start with an overview of our deployment diagram. So this is what our physical deployment will look like very soon. It's not quite as complicated as that right now, but we do have all of the different logical components that you see there. Basically, you remember I talked about the session servers in the very first diagram, the ones that connect an agent and a viewer or multiple viewers. So those are there. We try to choose, when we're choosing a session server for a particular agent, we try to choose a session server that is close to that agent geographically, so either just by checking it's in the same country or a country that's close by, or by checking ping times or round trip times, because that will minimize the latency between the agent to the server to the viewer. So we do that. And then the provisioning servers, they are stateless servers in and of themselves, but they talk to this old school relational database that's used to store global state. And what do we have in there? We have information about user accounts. We have the photos and names and titles of all the agents. You saw in the UI before that the customer is greeted with a photo of you, essentially. The provisioning database also knows about, or the provisioning servers through the database also know which of the different clusters of session servers should be used for a given session. So if I want to connect to a session that's hosted by an agent in Iceland, then there will be a lookup in the provisioning server to check, okay, which cluster to talk to. Okay, Icelandic cluster, let's go there. And then once you're inside of the cluster, there's an in-memory distributed database within the cluster to find the particular machine where that session is hosted. Let's see. We also have this geographically distributed logging backend, essentially a database as well. And we store diagnostic logs, error logs, and things like that in there. We also store custom log messages like, hey, a session just started, or hey, another minute elapsed in this session. Information that is our ground truth when we're calculating how much our system is used, how to bill our clients, and so forth. As you can see, we're in Amazon and we are hosted at Nýherji. Everything is in the cloud with us. We use Nýherji for Iceland, and it's a VMware ecosystem cloud. And then we use Amazon everywhere else in the world. And in Amazon we use like EC2 for virtual machines. We use SES to send emails. We use RDS to manage our provisioning database and replicate it. Whereas with VMware, right now we primarily run session servers. But it's really nice to be in both of those ecosystems. Let's say we were going to service a customer in, let's just say, Yugoslavia, where there's no Amazon data center really close by, but there's almost certainly a VMware ecosystem data center, because those are all over the place. So we could then put a session server somewhere close to that customer. All right. The other nice thing about being in the cloud is when we're doing updates, let's say we have 10 session servers, we can temporarily over-provision so that we have 20. And now we have 10 session servers running the old software, 10 running the new software, and those 10 that are running the old software, we will only turn them down once all of the sessions ongoing have finished. So we can do updates like that without any downtime. And being in the cloud makes this easier. Otherwise, we'd have to have twice the hardware or something like that. And this is just something we do for a few minutes or half an hour or so. All right. Let's talk about our server-side technology stack. So we already mentioned Amazon and VMware. I won't talk more about that. The relational database we're using is PostgreSQL. Very nice database, but not much to talk about. We also use Nginx, a very widely used open source web server. We use it as a reverse proxy into each of our different clusters. And now the juicy bits that you probably want to hear more about are how and why we use Erlang and Elixir. Who here came to talk about Erlang? Let me see. Show of hands. One person. Yay. All right. So we use Erlang for our session servers, the ones that are connecting agents and viewers and moving data between them. And the reason is that Erlang is particularly well suited for this purpose. So Erlang is a programming language and runtime that originated within Ericsson many, many years ago. And they initially designed it to work with their switches. And what do their telephone switches do? They establish a phone call between two or more people. If for whatever reason a phone call fails, you don't want other phone calls to fail, you don't want the whole switch to fail. The phone call is represented as a lightweight running process. And if you just replace phone call in all of those sentences with screen sharing session, you'll see that there are a lot of parallels. It makes a lot of sense to use that. And it's not just designed to make this possible, it's also programming this kind of system in Erlang is kind of beautiful. You have all these very lightweight processes, and they're lightweight enough that you can create however many you want, enough that you can represent your system sort of correctly. Any transient stateful actor, like an agent or a viewer or the session they're connected to, each of those you can just represent as a process. And processes only communicate by passing messages. And you can also pass messages within a cluster of machines just the same way as if you were on one machine. Erlang also has this, the next question is, what is Elixir? Elixir is a more modern language than Erlang, but it runs on the same virtual machine. And it also has almost all of the same semantics, just a nicer syntax and some syntactic sugar. And why do we use it? Well, we needed a clean web framework to do lots of database stuff, UI stuff, and we figured, and Erlang itself is not very well suited for that, and we figured if we choose the Phoenix framework, which is on top of Elixir, then we get code sharing with Erlang because it runs on the same virtual machine, and we get message passing for free between the provisioning servers and the session servers, which is a really, really nice feature, and this has proved to be a very good choice. All right. Now there are a number of trade-offs we've had to make in this system. The first one is compatibility versus quality. So we find it more important for the business problem that we're trying to solve that CrankWheel should work on practically every browser out there without ever needing a download. So if we were to allow a download, we could get, crystal clear 30 frames per second HD video. The networks today are good enough for that. But because we don't allow a download, we have to sacrifice something. So we sacrifice some quality. And what quality do we sacrifice? We primarily sacrifice frame rate. So we get lower frame rate, but we maintain legibility of what you're showing. So we find it's more important for the customer to be able to read the document you're showing to them or the web page than for them to get everything at 30 frames per second. Now this means we're not perfect for demonstrating something like a fast-paced action game, But again, that's something we could improve in the future as a special case. And now lastly, as I hinted at, we're not using WebRTC's peer-to-peer communication yet. And that's because we're basically sacrificing cost. We're paying more money to get faster speed of development. Because if we used the peer-to-peer capabilities, we would now have 3 clients instead of 2, and that's more code to maintain. And that third client would be fundamentally different to the other 2, which would slow us down. There would be more testing, more problems, harder to do rapid feature delivery. But it's something at some point we will probably do. We'll add a WebRTC client because it will save us a ton of money in hosting costs, because the traffic now is peer-to-peer instead of all going through our servers. And it should also improve quality in some scenarios. Okay, last slide. So just wanted to talk about some optimizations we do. So we build on the web platform, and the only networking connections you have available on the web platform are reliable streams. So who here knows over what kind of network connection real-time video has classically been sent? Is it reliable streams? No, it's datagrams, it's UDP, something like that, where the codecs are designed to sort of gracefully downgrade the video quality if there is some packet loss. But we're stuck because we want to be compatible, so we're on the web platform. So we're stuck with reliable streams, and we have to do something to respond to network conditions. So effectively what we do is we monitor the round-trip time from when we send an update to a viewer until that viewer tells us, well, I've visualized this update, I've shown it. We monitor the round-trip time, and if the round-trip time is unacceptably long, we start sacrificing, we start basically lowering the frame rate or increasing the compression ratio, or both, until we get to the lowest quality we're willing to send, or an acceptable round-trip time. The other thing is that there are 2 possibilities for bottlenecks, and when you have a reliable stream, bottlenecks are a big problem, because in a reliable stream, you will go through every single packet that's in your bottleneck before anything else happens. So what you can do is you can optimize queues. So there are 2 bottlenecks possible in our system. One is from the agent up to the server. The other is from the server down to the viewer. And what you can do is you can monitor these queues. And let's say one of the queues is really long. One approach would be to just, hey, instead of sending this whole queue, I'm just going to delete it and put a new keyframe in there. Or I'm going to remove everything from this queue except for the latest keyframe, because everything else is redundant information. I might send 10 keyframes and lots of delta updates, but in the end, I'm going to show the latest keyframe. Or you can consolidate delta updates, or you can recompress on the server at a higher compression ratio because you know that the viewer is getting too slow. Lots of things like that. I think you get the idea. All right. So I was pretty sure I was not going to talk about these because of lack of time, and it turns out I'm completely right. Putting these up there for you to ask me if there's time in the Q&A or afterwards. We have a booth upstairs, right up the stairs, so if you want to come talk to me or any of the team afterwards, we'd be happy to answer any of your questions. Now, in closing, a friend of mine told me, never miss the opportunity when you have a room full of people to ask them to do something. So I'll ask you to do 2 things apart from visiting us in the booth. So three things. Visit us in the booth. You can go to crankwheel.com right now and download our stuff, try it out. It's completely free. And third thing, we are always looking for talent. A lot of the things I talked about are either on the drawing board still, or they are in very preliminary implementations. So we have a lot of work to do to improve the system. And we also haven't yet discovered all of the different things we need to do to continue making sure CrankWheel is the very best screen sharing system in the world. So if you find this intriguing and you'd like to join us at some point, please get in touch with me. All right, that's it. And now let's take it away with questions. I think we have a couple of minutes, 1 minute?
For real this time.
For real this time, yes.
Go ahead. Any questions and opportunity?
One question regarding who is the target users?
Right, good question. Who is our target user? So we are primarily targeting sales professionals and customer service organizations. So we have yet to find out which of those 2 targets are converting better in terms of wanting to use the software. But it's primarily salespeople who spend most of their day on the phone, or a large part of it, and want to be able to skip the follow-up meeting instead of having a phone call where there's interest and then having to say, oh, let's meet in 3 days. They can just do the demo right away or show the presentation right away. Or customer service professionals where you have a customer calling in and they have a problem, and it's really hard to explain it to them without visuals, so you add CrankWheel and now you can just show them how to use your website or show them how to get around, something like that. Or show them information visually. Any other questions?
Yeah, can the user take control of the presenter's keyboard and mouse?
Okay, the question is, can the user take control of the presenter's keyboard and mouse? Not at the moment, no. It's something that is, would be a possibility for us to do, but not right now. Any other questions? Oh, there's one here, I guess. Yes, this would be perfectly safe to use. It's always an agent, like a salesperson or a service agent, showing the customer something from the agent's screen. So it's perfectly safe to use in any situation. So for instance, in banking, you would not be taking over the customer's internet banking. You would have like a demo bank where you would show them how to do things. All right? Well, I guess that's it. Thank you very, very much, and enjoy the rest of the day.